Hi viewers, welcome back to the lecture series of modeling technique. Today we shall try to discuss central tendency and measure of dispersion, which is module 4 of module 1 of chapter 4 of your modeling technique syllabus. So in this chapter, we shall try to focus on the three main measuring parameters for the central tendency like mean, median, mode, along with the other criteria like range, standard deviation, etc. And also how this thing will be calculated manually as well as using automated analytical platform. So let us start with first topic called central tendency. As it is written that central tendency means it is basically to find out the central value of a statistical quantitative information, or you can say the average value also. So there are three main measuring parameters of the central tendency. First is mean, median, and mode. And the relationship between these three central tendencies are mode is equal to 3 median minus 2 mean. That is the formula. So let us start with the first one called mean. See, when we have to compute the mean for a set of observation, then we can compute the mean based upon ungroup as well as the group data. For example, the formula of calculating the mean for ungrouped data is mean is equal to summation of x, means the summation of all the observation divided by the total number of observation, that is it. But if we have to compute the mean for a group of data or a level set of data where the frequency or occurrence of each of the attribute are also there, in that case our mean will be summation of fx by summation of n, where f is the frequency. We will discuss in the later slide with the hands-on. The third formula, that is also known as the shortcut formula or the assumed mean formula for mean calculation, says that the mean for a group set of data which are mostly classified, or the class interval set of data, are written as AM, that is assumed mean, plus summation of fxi by n into small I, where I is the class interval, AM is the assumed mean that we have to compute. You see, this x bar is equal to the midpoint minus assumed mean by the size of the class interval, that is I. So we have to compute that. Once this x dash will be computed, in that case we will put it into the original formula with some other n, am, etc. in order to compute the final mean. Let's have some hands-on. Like in the first table, it is written that we have to calculate the mean from the following frequency distribution by direct method. Direct method, as it is written, that means we have to compute by group mean method, that means summation of fx by summation of n, where you see the summation of f is written there, x is also written. How this x will be computed? 44 is the first class, the mean of this 40 to 44 is 42, and so as the other cases. Once this x and f is calculated, then you can multiply this x and fx, and then finally you have to calculate the summation of fx, which is written there, divided by n. N is the total number of frequencies, or the sum of total frequency. So in that manner, we can calculate the mean, that is 67 point something. Now, calculate the mean using the shortcut method. As we discussed in our last slide, the shortcut method means the assumed mean you have to take in, you have to compute the x dash, and then you have to apply this x dash there in order to calculate the final mean. Since if you carefully watch over there, 80 to 89, 70 to 79, these are the class interval which is not very much aligned. So we are making them align in this manner, like 80 to 89, 70 to 79, this is the F. So how you are computing this, how we are computing this X dash? X dash is computed by this mean point minus assume mean by the size of the class interval, right? So using this, we are calculating the X dash, as well as once you calculated the X dash, then you multiply F with X dash, and finally you have to take the summation of Fx dash, which will be written there. By the summation of n is 50 already, and I is the class interval, which is 10, because the class interval is 10. And the assumed mean, how we will take into account the assumed mean? How many observational entities are there? 1, 2, 3, 4, 5, 6, 7, 8. So since there are 8 entities, that means we have to take in the fifth number entity, and this one 40 to 49 as our central countable mean. So 40 to 49 means 44.5. So 44.5 will be assumed mean. And once you put the assumed mean 44.5, then Fx dash, which is 29, divided by summation of n, which is 50, into the class interval, that is 10. You can very easily compute the mean using shortcut method, that is 50.3. I hope this is clear. Move on to the next, that is called median. So same manner like the mean we calculated for ungrouped data as well as for group data, similarly the median can also be calculated. But remember, while we are actually calculating median, some different sort of for even or this type of concept we needed to be taken into account. Like in a class of 9 students who have scored the following marks is written 26, 12, 8, 13. In a vocabulary test, find out the mean. So how we will compute the mean? First, we have to check how many observations are there. That is in 1, 2, 3, 4, 5, 6, 7, 8, 9. Since 9 is basically an odd number, for this odd number, the mean will be n plus 1 by 2th item. But if it is even, then in that case, n by 2th item can be taken as mean. So 9 plus 1 by 2, that is 5th item. So the 5th item will be what? What will be the 5th item? You cannot say the 5th item will be 1, 2, 3, 4, 5. That is 7. No. Remember from our previous discussion during your graduation time also, or from your semester 1 QT classes, whenever you are going to compute the mean, at that time you should arrange this data into a sorted order. So once you arrange them in sorted order, you will be see at the 5th number place 9 will become. So the 5th item 9 will be the median. I hope it is clear. Similarly, for group set of data, means there will be some class interval or the frequencies are given at that time, you can compute the median using this formula, where L is equal to the lower limit of your median class. For example, you take in one median class 40 to 49. So 40 will be your lower limit and 49 will be your higher limit, and I is equal to 10. So this is L is equal to lower limit, n by 2. What is n by 2? N by 2 means it is basically the cumulative frequency just after your median class, means the next one. And what do you mean by FM? This FM is written there. This FM means the frequency of your median class. And this capital M means the frequency of your class interval below the median class. So there are three concepts. One is n by 2, one is FM, that is your frequency of the median class, and F, that is basically the frequency of the class interval below the median class. So you have to be very cautious while computing that. So this is the generic formula of calculating the median for a group set of data. So let's have a look with an example. You see, that is again a group data given to you with some class interval like 10 to 19. For example, we taken this or this, whatever. You taken as the your class, median class. In that case, what will be the lower limit? The lower limit will be 49.5. This one, because you have to slightly adjust, 50 will be 49.5, so that it will be coped with this. This is 49.5. Again, it will be start from 49.5 to 59.5. This is 59.5 to 69.5 and so on, so that there will be always a consistency. I hope this L is clear. Okay. Then what will be your F? The F will be what? The F is basically, if we already said in our previous slide that just after that class, you see, F is what? The cumulative frequency of the class interval below the median class. Okay. So this will be the F, and Fm is equal to 2. If you take this, in that case, your median class Fm will be this one. I is equal to 10. Okay. And n by 2 is equal to n is equal to 11. 11 by 2 means 5.5 is your n by 2. Now putting over there, 5.5 minus 4 divided by 2 into 10, that is this part, and your lower part or L of your median class is 49.5. Altogether, the answer will be 57, which is the median for this particular given problem. So in this manner, you can calculate the median for a group set of data. Move on to the last part of our central tendency called mode. The formula of mode for a label data where the frequency are given is a mode is equal to L0. L0 is the lower limit of the model class. F2. F2 is the frequency of the class after the model class or the mode class. And F1 will be just before the mode class. Okay. And F0 is basically the frequency of the class preceding the mode class. So three concepts are there. One is F0, second is F2, and second is F1 or Fn. Fn is your frequency of your mode class. F2 is basically the frequency of the class preceding the mode. I will discuss. Like one example is given. Please remember this particular formula of mode for group data. And once this is given, for example, the marks obtained by a number of students is listed there. Now, for example, 1, 2, 3, 4, 5, 6, 7, 8 means the fourth. Okay, 1, 2, 3, 4. Okay, so this 20 to 25 we are taking as our mode class. If you are taking that, in that case, our 20 to 25, this class, if you've taken your model class, in that case, L will be 20, Fn, it will be 25, F2 will be 10, and F1 will be 6, just before the class. I hope this is clear. Once it is calculated, you can always have very sophisticated amount of mode value easily computed from there. So this is all about the mode calculation. Move on rapidly to the measure of dispersion. Central tendency, as I said, is given you a single value which represent the whole value for an entire set of population. For example, 10 student average height will be given you a some kind of idea that, okay, if this will be the average height, then more or less each student will be having that much taller. Whereas the measure of dispersion will help you to study the variability of the item. It's much more wider scope. It's not depend upon a single value. First, it measures the variation of the item among themselves, and second, it measures the variation. In this manner, it used to be. It has again a lot of things to discuss, like the range that you know very well. Range you can very easily calculate it by L minus S, where L is the largest value and S is the smallest value. Okay. For example, the marks obtained in your previous semester result will be between the range of 0 to 100, because these two are the specified limit of lower and upper threshold. Next, the quartile deviation. The quartile deviation is the measure of dispersion. In this method, the difference between the upper quartile, that is Q3, minus lower quartile, that is Q1, is called the interquartile range. Please remember that. The interquartile range is equal to Q3 minus Q1, where Q3 is the upper quartile and the Q1 is the lower one. And the formula will be like this. Q3 minus Q1 is interquartile range, and the coefficient you can also very calculated in this manner. Okay. The last and the important part is the standard deviation. Let me tell you, in the measure of the dispersion of the standard deviation, method is the most widely used method. Okay. It was first developed by Carl Pearson. That's why sometimes the coefficient is also termed as Carl Pearson coefficient. And according to that, your standard deviation is known as the root mean square of your deviation, like this. So this is standard deviation symbol is equal to root over of x minus x bar, that is the deviation by n minus 1. In this manner, you can calculate that. And the variance is just what? In a single line, you can say the variance will be the square root, which is equal to standard deviation. Means the variance is equal to the square of your standard deviation. So this is all about the relationship between the standard deviation and variance. Example, the coefficient of variation is the relative measure of the dispersion, which is also computed in this manner. One particular example is listed there. For example, the question is below the table showing the value of the result of two companies. The first company A, where the number of employees work 900, average daily wages are rupees 250 each. The variance is given. That means we have to compute the standard deviation is 100. Whereas for the second company also the parameters are given. Now the question is, which of the company has the largest weight? Second, calculate the coefficient of variation for both the company. Third, calculate the average daily wages for the variance of the distribution of wages. So these three you can very easily compute by using HD is equal to root over of variance, because the average daily wages are given, that is mean, and the variance is given, that is 100. So if 100 means the square root of 100 is equal to standard deviation. In this manner, you can very easily calculate. I hope it is clear. Same concept of this mean, median, mode, as well as the measure of dispersion like the standard deviation and the variance, interquartile range, lower, upper quartile, we will discuss in our lab session using analytical platform like our SPSS. So join me in our lab class. If you have any queries, you can mail me.